All right, the first question here asks us to find the x values that the graph of y equal f of x intersects the x-axis. Remember, if something intersects the x-axis, let's just talk about that real quick. Here's your basic graph, right? If something intersects the x-axis, when does that happen? Well, here's the x-axis, right? Let's use a highlighter. That right there is when y equals 0. So since that's when y equals 0, essentially what we're doing is we're saying, okay, we want to know when this is 0. Well, when does f of x equal 0, essentially? So we're allowed to just replace that with a 0. That's step 1. All right, and then we see, okay, if I have a 0 on the left and I have a negative 16 over here, what I need to do is add 16 to both sides. And then I would have 16 equals x minus 1 in parentheses squared. Okay, now I need to take the square root of both sides to get rid of this square. When I take the square root of 16, I get plus and minus 4, right? Because the square root of 16 is plus both positive and negative 4. Over here, the square root and the square cancel each other out, so I just get x minus 1. And then I need to add 1 to both sides. Add 1 here, add 1 here. That cancels. So I have my answers. My answers are x equals positive 1 plus 4, which is 5. And it equals positive 1 minus 4, which is negative 3. So it equals both of those values. All right, let's go to number 2. Number 2, it just says solve. So we could solve it any way we want. We could maybe use the quadratic formula. We could use completing the square, but really I think the easiest way to do this one is by factoring. And you know I like to factor with the star method. So we need something, we need to multiply 7 times 28. So that gives us 196. 45 goes down here. We put the 7 in the wings, 7 in the wings. Okay, so what we need something that multiplies up to 196 and adds up to 45. So I don't know what that is, so let's just start listing our numbers. I could do 1 and 196. Now, one of these has to be negative because it multiplies to a negative, and it adds to a positive, so that means the smaller one has to be the negative number. So negative 196, those are factors. That doesn't work. So negative 2 and 98, that doesn't add to 45. 3 doesn't go into it, so we could try 4. We get negative 4 and 49. And you could just use a calculator to get all these guys, like just do 196 divided by 1, by 2, by 4. And we could keep going, but really we just found them. It's got to be negative 4 and 49. Now, at this point, I told you, you have to reduce if you can. So on the left side, it does not reduce. On the right side, 49 over 7 does reduce down to 7. Now remember, all we did is factor it. And the factors are not our zeros. The factors are always the opposites of our zeros. So that number right there, that is not your 0, but one of your zeros is positive 4 over 7. And that right there, 7 is not your 0, but one of your zeros is negative 7. Okay, and so those would be your two zeros, positive 4/7 and negative 7. All right, let's go to number, oh, by the way, could you take these, plug them in for x, and see if you get 0? Yeah. Could you take negative 7, plug it in for x, see if you get 0? Yeah, you could, and you would get 0 because these are the right answers. If you get the wrong ones and you plug them in, you won't get 0, and then you can know, oh, that's not the right answer. So checking your work might be a good idea. Same thing up here. If you took 5 and plugged it in here, look, 5 minus 1 is 4. 4 squared is 16. 16 minus 16, 0. Negative 3 minus 1 is negative 4. Negative 4 squared is positive 16. 16 minus 16, 0. So it might be worth it to check your work just to make sure you actually get it right. All right, number 3, complete the square to rewrite this expression in the form x plus a squared plus b. A and b can be positive or negative. All right, so I'm just going to go through the steps. You should have your notebook. You should look at the steps. If you don't have them memorized by now, write them on a 3x5 card. But the very first step is to simply take your c value, which in this case is 1, and move it off to the side so it's out of the way. Then the next step is take your b value, which is 12, divided by 2, and square it. 12 divided by 2 is 6. 6 squared is 36. So we get this magic number of 36. We're going to add 36 and subtract 36 at the same time. If there was an equal sign, I could add 36 to the other side, but there is no equal sign, there is no other side, so I have to do this little add and subtract trick. Now, that right there is a perfect square. Fits our pattern for the perfect square, so we could write it as a perfect square. It's going to be x plus 6 squared. Now, why is it 6? This number 6 will always be half of this number or the square root of this number. I should say and the square root of this number. And I know it's positive 6 because there's a positive there. All right, so that's how you can know what's going to go there. It's always going to be half of this. And if it was negative 12, it would be negative 6 here. And the square root of that. And over here, negative 36 and 1 make negative 35. And there we have it. We've written it how they've asked. X plus 6 squared minus 35. Boom. All right, let's take a look at the quadratic formula problem. Now, before we can use this quadratic formula, this thing has to be equal to 0. Right now, it is not equal to 0. So what we have to do is we have to subtract that 5x from both sides. I'm going to subtract it from the 26x because they're the like terms. And I get negative 9x squared, positive 21x plus 48 equals 0. All right, now I know that negative 9 is my A, 21 is my B, and 48 is my C. If you remember, I like to do the discriminant part first. Might be a good idea also, I'll do this in blue, is to just write the entire formula down somewhere on your problem. Just so you have an idea where you're going. All right, we'll come back to this in a little bit, but I like to do the discriminant. We could keep in mind that it's underneath the square root, but for the most part, we're just working on simplifying all this. So your B is 21, so I got 21 squared minus 4 times my A is negative 9 times my C is 48. All right, 21 squared, what is that? That is 441. And something interesting happens here that I see students make the mistake a lot. See how you have a negative or a minus here times a negative? That means this is going to turn into a plus. So when you multiply these, just know you're going to get a positive amount here. You're going to be adding because you have a negative times a negative. So I don't know what 4 times 9 times 48 is, so I'm going to use my calculator real quick. 4 times 9 times 48 equals 1728. And when I add those together, 2169. So I have the square root of 2169. Now, I could go ahead and plug that in here, but remember, I need to simplify this if I can. So let's just see if we could simplify this. Are there any perfect squares that go into 2169? Well, right off the top, I can't tell exactly, but I do see that maybe all these numbers add up to something, and we could try the 3 trick or the 9 trick. So let's just see. Does a 9 go into it? Because 9 is a perfect square. 2 plus 1 is 3, plus 6 is 9, plus 9 is 18. 18 is divisible by 9, therefore this number is divisible by 9. So let's do 2169 divided by 9, we get 241. So square root 9 divided by, or times square root 241 is the same thing as 2169. The square root of 9 is 3, so this simplifies down to square root 241. Now here's the thing, this is a pretty tricky one, this is hard. This doesn't simplify anymore. 241 is a prime number. And the way you could check that is just start picking smaller prime numbers to see if they go in there. Like try 2, try 3, then 5, then 7, then 11. And then pretty soon you'll see there is nothing that goes in there. And we don't even need prime numbers. We need perfect squares. So you could even try perfect squares. You could start with, well, 4 is not going to go in there because it's odd. So you can start with 9 and then 16, 25, 36. Just keep going. Eventually, you're going to get past 241, and you're going to realize none of them go in there. So you could check that on your calculator just if you weren't sure, but it is a prime number, so we're done. All right, so let's go back over here to the quadratic formula then. X equals negative b. All right, negative b. Well, my b was 21, so I'm going to write negative 21. And then instead of this whole thing, right, I did all the work here. Right, I did all the work and simplified down to that. So I'm going to write plus or minus 3 square root 241 over 2 times my a. My a is negative 9, so 2 times negative 9 is negative 18. All right, now we need to reduce if we can. A couple things I want to point out. Sometimes students think that they can reduce with things in here. Well, we already said this was a prime number, so it can't reduce. But if you could, like let's say this ended in a 2, sometimes students think, oh, I could take a 2 out of this and a 2 out of this, and I could reduce. Absolutely not. You cannot just reduce inside a square root with something outside a square root. But you can reduce things outside a square root with something outside a square root. The only thing is you have to do it to everything. You have to do it to all 3 of these. If you don't do it to everything, it's not really reducing. So yes, we can take a 3 out of everything here. In fact, what I would recommend is I would recommend taking a -3 out, because that's negative, and this number right here is already both positive and negative. So if you take a negative out, it doesn't change. It's still both positive and negative. So if I take a -3 out of that, it becomes +7. That becomes 1. That becomes +3. So the best answer for this using the quadratic formula is 7 plus or minus the square root of 241 all over 3. It's the best answer. Now I think you probably got an answer in the study guide that had the 2169 in it, but that's why I said that answer choices need to be simplified, or may still need to be simplified, because my computer program can't simplify square roots like that. So there you go. There's your answer. Good luck. See you guys on the quiz.